Alright, let's solve today's Leetcode problem. So today's Leetcode problem is a maximal rectangle. So we're given a rows and column binary matrix filled with 0 and 1. We have to find the largest rectangle containing only ones and return its area. So area in here, does it mean like to the combination of the width and height? That means like width multiplied by height. So that is the area of the rectangle. And then we only given the numbers filled with 0 and 1 for binary. So we don't need to worry about what are the other number that is going to involve in our matrix. So going to their XML, so we're given like a two-dimensional matrix, which is only include the 1 and 0. And then in here is given like 1 0, 100, 1 0, 1 1 1, 1 1, 1 1 1, and then 110. So by checking that, it is even highlighting here like this portion of the 1 can consider the maximum here. Why not the area in here is also the rectangle? Why not the area only in here? So by checking that, what we can think of is, how about this one? That is also the one of the rectangle, but if we combine these values, that is only the 3. How about this? That is also the great maximal rectangle. So that is considered 5. How about this? That is a 4. And then this one is suggested by the question, ends up is a 6. So the same for the element 2, since element 2 is only given the matrix of the 0. So we just return output 0, since if there is no 1 numbers in the matrix, we just need to return to 0. The same for the element 3, we only have a 1 number in the matrix, and then the answer is exactly the 1. I think that's exactly the dynamic programming topics. Yep, and some kind of stuck in here. So what I can think of is how about we just trying to populate the given numbers into the one-dimensional array so that we can easily populate the values that we could index from 0 till the end of the matrix. So my idea was just calculate the rows that we know of it, will be the matrix.count, the columns is going to be the metric of 0 of count. So we can trustfully do the metric of 0. The reason why I'm checking the constraint in here, so I'm pretty sure that the rows and columns start from minimum of 1. That means there will be exactly 1 numbers in the first row of the matrix. Alright, so moving forward, I'm gonna create the array called height that is going to be the exactly as the column. Let's call it like array of repeating of 0, and the count will be the columns. And then I'm gonna iteration through like what is the row we could get in 0 truths rows and column in 0 truths column. Okay, that will be the only 2 dots. Alright, and then I'm gonna check if our metric of rows and column is equal to 1. Yeah. Okay, because this is a character and we are using it as a character, which is going to be the string letter with the 1 values. And then if it is 1, we can convince the height of column will be the plus equal to 1. So I'm just creating the array in here just to keep track of how many ones, consecutive ones in here. In that case, 1 1 1 1 is 4 in here. Okay, I'm gonna write down in here 4. So let's call this is only, if I have to print that out, so we don't have any number of 1 initially in here. So that's going to be the only 1. This is going to be the 0. This is also going to be the 0. This is going to be the 3 because there's a 3 consecutive. And then this is going to be the 0. So it's a 4003. So that's what we are expecting here. If it is not, I just change the colon into back to the 0. And then I'm going to return the -1 here initially. How about we print out the height after we have done all the population for just for the height only. Okay, let me check. What did I do wrong? Colons. Okay, this should be the var, not the let. Right. So that's exactly what I want to calculate. So by calculating the numbers in here, only the 1 is vertically stacked consecutively or not. If it's not stacked vertically consecutive, we are going to result it back to the 0. This is how we got the 0 in the first index of the row. The same for the here. So this is going to be 0. So as I mentioned here, 40030. This is 40030. Yeah. All right. After receiving our one-dimensional matrix of how many ones are consecutive in here, we can easily calculate like what are the largest rectangle area. How about we create the separate function for that? I was thinking like create the separate function like largest rectangle area in here, which is going to accept the height of, okay, I was thinking like should use the height on, okay, just use the height here, and then that would be the integer array, and then we're gonna return back what is the largest area we can receive from that population of the height. So to calculate it, let's call this is the height. It's going to be the height. So the reason to do it like that is I want to make the heights very changeable. So if in Swift, we are not allowed to directly change the parameter values in here. So we have to partially revert back into the variable if you want to make changes in the parameter variables. That is one thing I can do that in Swift. If not, the another approach I can do is use a parameter called in-out in here, but I don't want to use that. So what I am trying to do is I'm going to append the one arbitrary numbers, which is a 0. This is just for the setting values of flash value. So if we have reached the starting point of the population matrix, I'm going to stop, which is going to be a stop point for us. So what I can say is currently we have originally is a 4, 0, 0, 3, and 0. And I'm just append the extra 0 in here. So that is what I append in here, this number. So moving forwards, I'm going to create the stack, which is just a format proper array, just to keep track of the indices of the increasing height. Let's call stack, and it's going to be the integer array. And how about we calculate the height count, because I don't want to use the height count as a different thing. Let's call height count, which is going to be the height star count. Yep, and let's try to do the iterated approach by using the for loop, like for index in height count, which is going to iterate from this number in here from Z, from left to right. So by checking that originally the number will be empty at first, so I can do like append the index number, so which is not going to be a weird for us. And what I need is I need to check what is the last number in our stack. Originally our stack is empty, so that is the reason why I'm appending the index at the end of the while loop. So, but inside the while loop, what's going to include is our last item of the stack, And then if the last item of the stack is a Z, we want to check what is the last index. Technically, we are putting the item in reverse way. So let's go, we have one array which is going to stack. And then I just append like from the last 0, something like this, 1, 2, no, 1, 2, 3, 4, 5. So based on that, we are appending our indexes to our stack. Okay, after we receive the stack, I will check like our last item of the high is greater than our current item of the high, which is indexing here. So technically, if I move to another stack, let's consider I have append like 0 and 1 only. And then, wait, it's 0 only, but next item is become the 1. Technically this one. So it's technically is index 1. So we are comparing the 0 and 1. So if we check the 0 of the high, so we are checking like if 4 and 0, which one is the highest? That's pretty sure. Our last item, which is 0, 4 is higher for sure. So if it is true, what are we going to do is we're going to update the height with the height of last item because we have received the highest number, and then I'm going to remove that from our stack because we have populated the number in our stack. So technically I'm only just removing the index from the array, and then I'm going to need the left index. Left index means we are populating the data from the left to right. So we want to check, we have received what is the highest number in here. So let's consider this is a 4 is the highest, and we want to find when should our rectangle should stop to become the proper and largest rectangle area. So that's easy to populate like by checking the stack dot less. If not, I'm gonna just put the default value as -1 initially. That will help us to calculate the width. So width will be the index minus left index. So the reason why we are getting the stack dot less is okay, I will write down the proper solution and it's trying to explain in the final part with the proper solution, which is easier for you guys to understand. So after receiving the width and height, I can simply calculate the area, which is a multiplication of the width and height. But we need to keep track of the mass. Let's consider like mass area is 0 in here. So that will be the mass of mass area with the height. If everything went well, I can just return the mass area, which is going to help us to populate the mass, and then I can use the, let's call it reset in here. So at the end of the for loop, we can do like reset will be the mass of reset and our private function rectangle area, and we just pass the height, and then I can simply return the reset in here. Let me check what did I do now in here. Stack dot less. That's weird. Let me check. I think I'm missing the sum operator or something in here. Stack dot less. Then we can check. Okay. have no idea what did I do wrong. But we have a stack in here, dot less. Okay, how about we don't use a unary operator? See how. I think something wrong with the stack. Okay, let me try to define the data type as an integer in here. And then this is going to be the empty initially. I think that this for the best. Let's try again with the -1 initially. Okay, that's weird. I was never thought like initializing the integer string with the empty parameter will be the difference. So if I have to iteration through approach for it, let me calculate this number in here, and I'm gonna drop the heights, which is going to be the like this in here originally, and then so we have a stack originally which is empty, and then we have a height of count which is going to be 6, and then we're going through like 0 to 5, 0 through 5, and then now we are at the 0. So technically speaking, we are checking the stack have a less idea or not. So since our stack is originally empty, we're moving forward to that, just appending our index in here, which is going to be just 0. And then moving forward, we get the less eigen, which is going to be the 0. And then now our index is 1. And then we will check the height of the less. Less is a 0, which is a 4. Technically, we are comparing the 4 is greater than to that. Now our index is 1. So 4 is greater than 0. Of course, it's greater than 0. And then we just populate the height of less. So our less number is 0, and our height is 4. So technically, we are keeping the 4 in here, and then we remove our number 0 from the stack. So now our stack is back to the empty, and then we will check back again like our stack.less has value or not, since we removed our only one item that's exit from the stack, and then stack gets back to the empty, and then we just populate with a -1. So technically speaking, we are population of like index, which is going to be the 1 at the moment, and then minus left index, which is going to -1. So technically like this, since we don't have a -1, and then we detect the -1. So since it's a two negative meet each other, became a positive integer, and then it's a 1 plus 1 is 2, 2 minus 1 is 1. So we have a width and height. So by multiplying our mass value originally is a 0. So 4 multiplying by 1 is 4. So we're gonna populate the mass area become the 4 in here. So this is 4. If I am not wrong, we are population of this area in here, 4. Yep. And then moving forward, we append our index, which is 1, to our stack. At the same time, high count is still the same, and then go to the mass area, and then our index began to 2. So since our index began to 2, we check like what is the last index of our stack, which is 1, because we just recently appended 1 into our stack. And then we are comparing like our height of let's, which is a 1, height of 1 is 0, and then same is 0. It's a 0 and 0 comparison, which is going to be the faults, and then we are not going to remove anything. We just append the 2 in here. Wait, did I do something wrong? So our less is doesn't exist. Less is 1. 1 is here. 2 is also here. So it's a 0, 0. And then we just append the 2 to here. So after append the 2, it is time to moved our index into 3, which is going to be the very interesting part. And then we will check like what is the last item of the index. Technically, we are speaking of the 2 because we just appended 2 recently, and then we will check like last index is 2, and then our index is 3, which is exactly the 3 in here. And then we are comparing like last item is 2, and then comparing with the 3, which is going to be false, and we just append the 3 to the stack. And then our index became 4, our last item became 3. We are going to compare like 3, and height of index is 4, which is 0, which is going to be the true. And then we just want the last number, which is the last number is 3. This is going to be 3, and then we're going to remove the last item. That is going to be like this. Okay, then it is the interesting part to calculate. Our stack to last is -2 in here, so we here 2, so which is becoming 2. So in here it is easier to calculate at the moment, since our index is now 4 minus what is our left index is 2, and then we minus 1. So 4 minus 2 minus 1 is going to be the 1. And then we multiplying by height and width. Since the width is 1, height is 3. So 3 multiplying by 1 is 3. So we are comparing like 3 and 4, which is the highest. So exactly 4 is the highest. So there is no reason we need to do anything. And then since we still have any number in the stack, so we move to the next in the while loop, stack.last begin the 2. And then we compare like height of 2, which is 0, and then height of our item, which is index, is 4. 0, 1, 2, 3, 4. It's 0 and 0, which is going to be the false. And then we move it forward, and we just append our index in here, which is 4. And then our index became the 5. And if our index became the 5, we have to check like what is the last item. So the last item is 4, and then this is a very interesting part came in. So since our index is 4, 0, 1, 2, 3, and 4 is a 0, and then our index is 5, 0, 1, 2, 3, 4, 5 is a 0 and 0, which is false. And yeah, and then if everything is false, we just move to the next step, which is appending our index 5, and then we just iteration out of our index into the 6. So I think that is our parts campaign already, since we have originally all the numbers are populated like one by one, since I was just showing that what is the last item look like. So at the end, if you try to iteration one by one, this is going to be the 2 multiplying by 3, and then that's where our answer came in. So if I have to check the time and space complexity, I think it will be the O of n into m, which is a row and column. I think the memory will be the O of column, since we only use the extra memory as a column in here. Right, that's all for this, and I'll see you in the next video. Bye.